Hello students, welcome to Unacademy. How are you? So I hope your preparation is going absolutely fine. And today we are going to start the new topic. It's basically one lecture is already done, that is fluid kinematics. So we are going to continue the same topic, that is fluid kinematics. So up to now, very basic discussion we already did, that what is this fluid kinematics and what are the type of flow. Then we discuss about the type of fluid also. Then we discuss about some of the important lines like streamline. Then we discuss path line, correct. Here today we will discuss one more line, that is streak line, as well as we'll discuss timeline also, right. And after that we are going to talk about the most important concept of this particular subject, I would say, that is a continuity equation. So we'll discuss here continuity equation also. And maybe you people, a few people may be new in this platform, so for those people I would like to tell something about myself. I'm Shivam Dixit. I did my MTech from NIT Calicut in thermal science. After that I got chance to work with India Corporation Limited R&D as automotive research officer. And from last 9 years, more than 9 years, I'm guiding the GATE and ESE aspirants, and up to now I have guided more than 50,000 students, and I, like many of my students, secured single digit and double digit rank. Even last year, like last year, AIR 3, Vishal Deja was my student. So it's a proud moment for every teacher that his students is going to be securing topmost positions. So I hope in future you are also going to be the in topmost positions, and I will be proud of you. Okay, this is all about me. So let's see. All right, let's see how's going on. Clear, beta? Okay, so shall we start today's topic? So you know the rule of this class, right? You all know the rule of the class, that you have to, whenever you came to the class, then you have to like the session first, and then if you are not subscribed, you can subscribe also. And immediately after that, whatever group you are belonging from, you just go there and write that class is live. Okay, so very good evening to all of you. Very good evening, very good evening. Who's that? Captain Raj, how are you? Oh, volume is low, sorry. Captain Raj, is it fine now? Is it fine now? Captain Raj, Jaychandra Kumar, very good evening. Captain Raj, very good evening. How are you? कैसे हैं? Audio, video, everything is fine. So shall we continue our discussion? Yes. So Captain Raj, I will request you to go in the the group wherever you are belonging from, and just write that class is live. Class is live. Clear hai? Okay, so let's start the session, right? Let's start without delay. Let's start the session. So basically we already seen that what is the streamline, right? A streamline is an imaginary instantaneous line, right? Imaginary instantaneous line. It is drawn in such a way that at any point if you are drawing the tangent, at any point if you are drawing tangent, the tangent is going to give you the direction of the flow. तो क्या देती है? डायरेक्शन ऑफ द फ्लो. सो इट इज बेसिकली नॉट गोइंग टू कनेक्ट द सेम पॉइंट, बिकॉज इंस्टेंटेनियस स्नैपशॉट ले रहे तो वहाँ एक पॉइंट थोड़ी ना आएगा, वहाँ तो देयर विल बी नंबर ऑफ मॉलिक्यूल, आई कैन से there will be number of particles, right? So this is going to be like imaginary line, and you cannot draw it exactly, like you cannot draw it practically. See, most of the time students are thinking that whatever lines we are discussing, that lines are actually drawn practically. All the lines are not drawn practically. Very important. Even extreme line also not drawn practically. Only this is defined theoretically, and accordingly we are going to use it for analytical purpose by using its equation. That equation I already told you, for 2d right, dx by u is equal to dy by v, correct? So that equation we already seen. Even we solved one very great problem. We already solved a good problem on that. Clear hai beta? Everyone, tell me. Right, let's talk about one, and path line also we discussed. Path line is for one particular molecule, right? Means if you just have to take one molecule, and that you need to check that where it is going to be follow, and you go and check beta, you go and check You go and check in ESE exams, in this 2-3 concept, number of questions are there, right? They may ask that whether it's a true or wrong, like they may ask that whether this path line can cut itself or not, or two path line can cut itself or not, or extreme line can cut itself or not, or two extreme line can cut each other or not. So there are number of type of questions can be framed. So you need to understand that it is that streamline is instantaneous line. Streamline is a instantaneous line, so this line is not going to cut itself, and it is not going to cut any other extreme line also. And you need to understand that the flow is always along the extreme line, because it is defined like that only भैया. वो defined ही किया गया है कि उसके perpendicular, like उसके tangent direction में flow होगा. अब जिसके ये direction में flow हो रहा है, इसका मतलब क्या है? इसका clearly मतलब है कि cross flow नहीं हो सकता है. You are getting my point or not? So whatever direction is there, what the direction at a point is shown by the tangent drawn on the extreme line. So the across the flow is not possible. Clear? Across the flow is not possible, it is always along. And if two extreme lines are there, between two extreme lines, I already proved that this particular point, even I will prove in future also, right? This one, right? This point, right? That if suppose two extreme lines are there, something like this, right? So between these two extreme lines, the discharge is going to be constant. Discharge is going to be, because whatever Q will enter, same Q will out. Whatever Q will enter, same Q will be out, because whatever discharge, whatever particles are entering, that cannot cross the line. That cannot cross the line. You are getting this imaginary line. Please try to understand. कल आगे comment नहीं करना सर, कैसे नहीं कर सकता बोलो. मैं बोलता हो सकता. अरे भैया कैसे हो सकता वो? That is an instantaneous line. Sir, if it is unsteady flow, अरे if unsteady flow, then every single second streamline will change. Extreme line is going to be fixed only for steady flow. ये बात नहीं घुस रहा तुम्हारे भेजे में. You are getting my point now. If it is unsteady flow and you are saying that it is going to, sir particle move कर गया तो क्या कर लेते? Particle तो independent. अरे particle move का तो unsteady flow होगा ना in that case. You are getting my point now. That will also, you can see that this reflection you can see in the continuity equation also. We'll see that. Don't worry, we'll prove that. Okay. So this is all about this one. Very good. SK, is it clear or not? अरे ये क्या बोल रहा है? Hello Shivam Dixit sir. Thank you Charan Kumar. Javed say good evening. Very good evening to all of you. Mr. Budge, very good evening. Okay. Now please listen here carefully. Now I am going to talk about today's topic, like extreme line. What is this? Sorry, streak line. Streak line is basically the line joining the position of the fluid particle which are subsequently from pass through the same point in the flow. Sir, कुछ समझ में नहीं आ रहा क्या बोल रहे? Don't worry. कुछ समझ में नहीं आ रहा सर क्या बोल रहे? Don't worry. Now please listen here carefully. What is the meaning of this? Suppose this is a pipe, right? This is a pipeline. Now here one tube is something like this. Right, one tube is something like this, one tube is something like this. ध्यान से समझना. कैसे समझना है तुमको? कैसे समझना भैया? ध्यान से समझना. Okay. Now इसमें हमने क्या किया? Right, what I did is I put here one yellow line, yellow what do you call? Yellow color ball. So after 1 second, one yellow color ball is coming out from this. After 1 second, this ball is here. After 1 second, after 2 seconds, this ball is here. But in every second I am dropping one ball. अरे देखो भैया इधर देखो, right? Every single second I am dropping one ball. So first ball मैंने drop किया, right? After 1 second it will be here. After second it will be here, right? Now then just after that, after 1 second again I am dropping one ball, that is let's say green color. So green color, after for green color let's say it is somewhere here. See, येलो के लिए 2 सेकंड हो चुका है. प्लीज ट्राई टू अंडरस्टैंड. फॉर येलो 2 seconds are over, but for green it is a first second only when it is coming out from the same point. You are getting my point or not? Okay. After 3 seconds what will happen? After 3 seconds, after third second what will happen? This point will reach somewhere here and green will reach somewhere here. After 4 seconds, what will happen? It will like blue will yellow will reach somewhere here and green will reach somewhere here. Clear hai? But just after green, one more ball was dropped. That is, let's say, which color? Yellow, blue color. So this blue color, for blue color only 2 seconds are happened. So it will be something like this. Then again, after some time it will be 3, and it will be like it will be somewhere here, it will be something here. Only three molecule I am taking. ठीक है? अरे भैया समझो, प्लीज समझो. आफ्टर, सो फर्स्ट बॉल डाला मैंने. क्या किया मैंने? फर्स्ट बॉल डाला. व्हेन आई पुट द फर्स्ट बॉल, then after 5 seconds this ball will reach here, then just after that, just after 1 second, again I'm dropping another ball, right? For that it is 4 seconds only na, so after 4 seconds it will reach here, after 3 seconds it will reach here, after 2 seconds one ball will be there na beta. अरे one ball will be after 2 seconds ना. अरे समझ में आ रहा है ना. So after 2 minutes, like one ball will be somewhere here. Let's say this is one, or this is another one. ठीक है? Then I am taking one more color, this one. So after 1 second, only one is here. कहाँ ड्रॉ करूँ, जगह ही नहीं बचा. ये यहाँ. और एक क्या होगा? एक one ball is just about to come. Now. After 5 seconds, how many balls are came? 5 balls. Arey, how many balls are came? 5 balls. And one ball is just about to come. Very good. Now please listen here carefully. I am going up after 5 seconds, process is stopped. And now I am not putting. Now at 5 seconds, I am going to draw the actual position of these molecules. So इसका येलो का पोजीशन क्या है? ये है. ग्रीन का पोजीशन क्या है? ये है. तीसरा बॉल का पोजीशन क्या है? ये है. इसके बाद वाली बॉल का पोजीशन क्या है? ये है. इसके बाद वाली बॉल का पोजीशन क्या है? लेट्स से ये है. इसके बाद वाली बॉल का पोजीशन क्या है? वो तो अभी अंदर ही है, राइट? ये हो गया. अभी ये लाइन जो ड्रॉ हुई ना बेटा, राम प्रसाद, चंद्रशेखर, दिस इज अ स्ट्रीक लाइन. अरे समझ में ही नहीं सर, इस स्ट्रीक लाइन का क्या मतलब होता है, क्यों पढ़ रहा है, क्यों नहीं पढ़ रहा है, कुछ समझ में नहीं आ रहा. वेरी गुड, इट्स अ जेन्युइन क्वेश्चन. It is a really a genuine question. It is a really a genuine question, that why we are studying. So one thing I would like to tell you, in many books this point is not mentioned. But always remember that streak point is going to be start from the right. कहाँ से? एक point कहाँ पे? One point is at the point where the particles are moving. See, it is the line obtained by the joining the position of fluid particle which are subsequently pass through the same point in the flow. तो ये एक सेम पॉइंट है जिससे फ्लो हो रहा है, उसमें हमने क्या किया? डाई मिलाया अलग अलग कलर की. सो एक कलर की डाई को इधर पहुंचाएगी, इधर पहुंचाएगी. तो फाइनल पोजीशन जब मैच करते हैं, then it is called as what? Streak line. Is it are you understand this? अरे किसी को कोई कंफ्यूजन है तो भैया चैट बॉक्स में क्वेश्चन पूछ लो क्वेश्चन. मना किया किसी ने? बाबू एसके बोल रहा है. बाबू कौन है तुम्हारा बाबू यहाँ पे हैं? इज इट क्लियर ऑन? तुम एस के स्टूडेंट हो तभी तुम ऐसा बोल रही. दीज आर माई डायलॉग्स. बाबू इज इट क्लियर और नॉट है? मेरा डायलॉग मुझे पे मार रहे हो. वेरी गुड. Now please listen here carefully. Everyone please try to understand this. This is very important. This is very important, right? This is very important that एक बात समझना, ये बात बहुत लोग, स्ट्रीक लाइन किसी को बहुत कम ही समझ में आता है एग्जैक्टली क्या मतलब है. मैंने क्या बोला कि अगर मैं इफ आई एम गोइंग, दिस इज ऑल्सो इंस्टेंटेनियस लाइन, दिस इज अ t इज इक्वल टू 5 लाइन. अरे t इज इक्वल टू 5 लाइन ड्रॉ है ना, ये 5वें सेकंड पर ड्रॉ किया है. लो राहुल अरे काट दिए तो काहे कॉल कर रहे. ओके, नाउ प्लीज लिसन हियर केयरफुली. अब मैं जो बताने जा रहा हूँ ध्यान समझना. दिस इज ऑल्सो काइंड ऑफ इंस्टेंटेनियस लाइन. दिस आई ड्रॉन व्हेन इट इज अ 5 5 second, right? After, let's say, after 5 second, like 6 second, what will happen, beta? 6 second, what will happen? Are yellow will be somewhere here, na? Are yellow will be somewhere here, na? Are green will be somewhere here, na? Correct, na? Then blue will be somewhere here, na? Blue will be somewhere here, na? Then red blue के बाद क्या थी? Blue के बाद dark blue था. Dark blue will be somewhere here, na? Then red will be red था ना? इसके बाद क्या था? Red ही था. Red will be somewhere here, na? And फिर एक नया ball आएगा, introduce हो जाएगा. Then a new ball is somewhere here, na? Then one ball is already inside, na? Right? Okay, one ball is all. Now you match the points. Then it will come something like this. अरे देखो बाबू, देखो. This is the streak line at t is equal to 6 seconds. This is a streak line at t is equal to 5 seconds. Many people don't know this. That is an instantaneous line, right? It is also instantaneous line. First thing. Second point is, it is going to match the final position of the each molecules which are actually passed from the same point, Now listen here carefully. Sir, what is the concept behind this? I'm not getting it. Okay, no problem. I'm here to explain you. Better don't worry. क्या मैं बोल रहा हूँ? अब ऐसे सोचो कि तुम्हारे पास एक रेस हो रहा है, राइट? इन लाइफ ऑल्सो यू आर गोइंग टू, भाई बहुत सारी रेस होती है, राइट? बहुत सारा रेस होता है, राइट? नाउ इन दैट रेस व्हाट इज हैपनिंग इज देयर आर, लेट्स से, सम कार्स आर देयर, राइट? सम पीपल आर देयर. So this is one person, one champak, right? This is another champak, right? This is another champak. There are many champaks. Green color se nahi draw karenge. There are many champaks, right? There are many champaks, right? ध्यान से समझेंगे. ये पूरा लाइन है, बहुत अलग अलग तरीके का लोग इधर बैठा हुआ है, ठीक है? सब तुमको ज्ञान देने के लिए रेडी है. एवरीवन इज रेडी टू गिव द ज्ञान. बट क्या लेने वाले आज के डेट में नहीं है? आज का दुनिया, पहले पता है, ट्रूली स्पीकिंग 10 year back down the line, right? 10 year back, people actually want a good education, right? They actually want some education. They want to study from the top faculties and experienced faculties, but it was not available due to constraint of that city. Constraint was there, location constraint was there, money constraint was there, many constraints are there. सारे constraint हट गए अब. फिर भी लोगों को नहीं चाहिए सर, पैसे नहीं. अरे पैसे फ्री में जो मिल रहा है वही कवर कर लो. जितने लोग, जितना फ्री यूट्यूब में कंटेंट अवेलेबल है ना, कोई उतना भी कवर कर लें तो 60-70 नंबर आ जाता है, IIT मिल सकता है. मैं बता रहा हूँ, ये हकीकत है. अब कुछ लोगों को लगता है अरे नहीं सर, पेड जब तक इफ़ आई विल नॉट टेक प्लस सब्सक्रिप्शन ना सर तो मेरा कुछ नहीं. अरे ठीक है, इफ़ यू कैन अफोर्ड प्लस सब्सक्रिप्शन इट्स फाइन. इफ यू कैन नॉट अफोर्ड देन एटलीस्ट स्टडी द पार्ट विच इज अवेलेबल इन द यूट्यूब ना. अब देखो इधर, now I started from this person, the first person start moving, right? So this champak reach here, right? Very good. After 1 second, then this champak is, after some time it will be here. Then blue wala will come somewhere here. Then this one, green wala भी start नहीं हुआ, right? Then next one, ये यहाँ पे है, ये यहाँ पे है. लेट्स से मैं 10 से, लाइक कितने सेकंड बाद देखो, 5. ओके 5 और थोड़ा बना देता हूँ. ठीक है, 1 2 3 4 5 6 7 8. After 8 seconds he will be here. After 8 seconds this molecule is going to be somewhere here. Now after some time what will happen? This molecule is going to be like 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7. Sir, how it is possible that this second person will be always behind that? No, not necessary. It's not a necessary, but it's not necessary. Okay. Then a green person will be somewhere here, like 1, 2, 3, 4, 5, 6. 6 हो गया. Then he will be 5. 1, 2, 3, 4, 5. Then he will reach 5. क्यों कर रहे हो इसको? ठीक है 5. Then 4. 1, 2, 3, 4. 1, 2. Okay, right. So how many? 1, 2, 3, 4, 5, 6. After 6 seconds, this is the position. This is the position after 6 seconds. Please listen here. And this is the this is one common location. ये common phrase है, right? From here, all the molecules are going to be passing. A race actually. So this race is going to be start from here. This race is going to be start from here. Now please listen here carefully. If I am going to draw, a line at after 6 seconds, what will happen? This person will be here, and then this person will be here, then we'll match this person, then this person, then this person, then this person, then this person. This is a streak line. A streak line at 6 seconds, at t is equal to 6. Then I will draw streak line at t is equal to 5 seconds. Then I will draw here t is equal to 4 seconds. So all these are the streak lines basically. All these are the streak line at a particular stage. So this is at 6. So every time it is changing. You are getting my point or not? Okay, now please listen here. Some points I am going to explain you. Very, very important points. The one why we are drawing this, because it is giving the relative position of the molecule. What is given? It is a relative position of the molecule. Relative position of the molecule which are passing through the same. मान लीजिए कोई कार रेस है. अब कार रेस में एक तो विनर हो गया, लेकिन जो सेकंड पर्सन है, थर्ड पर्सन है, फोर्थ पर्सन है, उन सब का ट्रैजेक्टरी अगर हम ड्रॉ करें तो इट विल गिव द रिलेटिव पोजीशन ऑफ द all the cars at the final state. You are getting my point now. Now here you can see that all the lines shape is different. All the line shape is actually different. Why? Because it is not steady. If it is a steady, then what? If it is a steady flow, then what will happen? The shape of the streak line is going to be same. Why? Because every molecule will flow the same way, na. अब तो this gap आ रहा है, gap will be always same, na. This gap is going to be always same if it is a steady flow. If it is steady flow, so steady flow, it is a similar type of pattern will come basically. So this is basically the streak line. So that you can see from here. Clear hai? So for unsteady flow, the path line and streak line all can be different, but it flow steady all these lines are going to be same. Obviously वो सेम ही पार्टिकल तो जाएगा ना, जब अरे जो पार्टिकल जा रहा है उसके बाद जो गैप आएगा वो भी तो सेम ही आएगा ना सेकंड पार्टिकल में, तो इट विल बी सेम बेसिकली. I hope you understand this one. That's why I draw this diagram. Clear हुआ है? Okay, so this is all about streak line. Now I am going to discuss about the continuity equation, that is today's topic basically. So today we are going to discuss about this content. This is very very important beta. Continue not only for this particular chapter, not only for this particular chapter. In complete fluid mechanics you are going to use this continuity equation, right? In complete fluid mechanics you are going to use continuity equation. Clear hai? Okay, now continuity equation is basically based on the law of conservation of mass. This is based on basically mass balance, right? This is basically based on mass balance. Clear hai? This is basically based on mass balance. Which one? Continuity equation. Continuity equation is based on mass balance. What is mass balance? Mass balance is, suppose you are sitting in one room, you are in one room. In that room 10 kg per second mass is entering, 10 kg per second mass is entering, 8 kg per second mass is leaving. So how much mass is going to accumulate? That is 2. That is 2 basically. So here if someone will ask you to write mass balance equation, then I'll write 2 is equal to 10 minus 8. Karina, why I am writing this? What is 2 here? 2 is the rate of mass accumulated within the control volume. Because we are dealing with what? We are dealing with Euler technique, right? In Euler we have one space. We are considering one space. And what is that space? Your room itself is a space basically. So in room 10 kg mass is entering, 8 kg mass is, 2 kg mass is accumulating. So in words if I say, then I can say that the rate of mass accumulating within the control volume is equal to the net rate of mass transfer, rate of mass entering minus rate of mass leaving. This is basically the mass balance equation. Correct. Sir, is it study or not? No, it's not study. Sir, why? Because mass is going to accumulate within the system. If mass will accumulate, then other property will also accumulate, because mass have energy also, right? So mass have energy, mass have temperature, so temperature may change, pressure may change, many things may be changed basically. So it is not study. In that case, what I can say that this equation is for unstudy, right? So I am writing in detail basically. So I can say that here I am writing rate of mass means dou m by dou tau or dou t. I can write time, t is time. So the rate of mass accumulating within the control volume is equal to rate of mass entering mi dot minus rate of mass leaving me dot, m in minus m out. अरे ये बात क्लियर हुआ कि नहीं हुआ? सर हो गया, सर हो गया. बट दिस इज फॉर अनस्टडी, दिस इज फॉर unstudy, this is for unstudy. Clear hai? Now for study what will happen? Sir, for study there should be no any accumulation of mass within the control volume. It means the left hand side should be 0. When left hand side will be 0, when m in is equal to m out, means basically what I can say that this value is going to be 0. So m in dot minus m out dot, or I can say that m in dot is equal to m out dot. Then I can say dot means what? Flow, rate of flow, rate of mass, right? So this is basically what? This is basically study flow. Clear hai? Unstudy flow and study flow. Is it clear to all of you? Clear. Okay, very good. So this is a law of conservation of mass. So if someone will ask you what is law of conservation of mass, if someone will ask you what is a law of conservation of mass, then you can say that the rate of mass accumulated within the control volume, the rate of mass accumulated within the control volume is equal to the net rate of mass transfer across the control volume. Clear? This is for unstudy. For study flow, the rate of mass accumulated within the control volume value is going to be 0. It means that rate of mass entering is equal to rate of mass leaving. इसमें किसी confusion? Sir, no confusion. Let's come to the continuity equation. First I am going to write the equation for one dimensional study flow. First I am going to write the equation for one dimensional study flow. Please listen here carefully. कोई भी बकवास नहीं करेगा. वेरी गुड. कोई भी बकवास नहीं करेगा. तो सर क्या करेगा? चुपचाप समझेगा. Now let's say I'm drawing this type of cross section is that. Please stop. Listen here. अभी क्या करेंगे? Now this is basically what? This is one state. So this is initial and this is 2. Now these 2 points I am taking means this is what basically beta, this is actually our control volume. This is basically our control volume. It may be nozzle, turbine or something, some open system. That's some open system basically, because flow we are discussing now, so it is an open system. So this is basically what control volume. This is basically what control volume. From here some mass is entering. What is entering beta? Or what is entering? M1 dot is entering. What is leaving? M2 dot is leaving. M1 dot is entering and M2 dot is leaving. Correct now? Now here first thing I am taking is steady. If it is a steady means no mass is going to accumulate within the control volume. It means that whatever mass will enter, same mass will out. And second thing, you can see that here only in one direction flow is there. Only one direction, only x direction flow is there. Only x direction flow. So this is one dimensional steady flow. So for one dimensional steady flow, I can say that M1 dot is equal to M2 dot. अरे समझ में आया क्या? बोलो समझ में आया क्या? One dimensional steady flow we can write M1 dot is equal to M2 dot. Now please listen here carefully. What is rho? Rho is equal to mass per unit volume. Very good. What is mass? Mass is rho into volume. Volume is area into length. Very good. Now divide with time. Both the side. Divide with time beta. Time. So m by time is m dot. M by time is m dot. L by time is velocity. So rho AV, I am writing rho AV, m dot is equal to what? M dot is equal to rho AV. So now here it is not mass. Rho AV is not mass. It is a rate of mass. It is a rate of mass. Now M1 dot is basically entering. M1 dot is basically entering. So I can say that here whatever conditions are there, because here area is different, here area is different. At A1 area is different. At at 1 area is different. At A2 area is different. At 1 velocity is different, 2 velocity is different, even rho also can be different. Okay, so I can say rho 1 A1 V1 is equal to rho 2 A2 V2. This is the continuity equation for one dimensional steady flow. Now please listen here carefully. ध्यान से समझिएगा, otherwise ये मिस हुआ तो लाइफ खत्म, राइट? फिर कोई मतलब नहीं फ्लूइड मैकेनिक्स पढ़ने का. Now please listen here carefully. अभी मैं क्या बोल रहा हूँ? If flow is incompressible और fluid is incompressible. For incompressible flow और fluid दोनों हो सकता है. Fluid भी incompressible हो सकता है, flow भी incompressible हो सकता है. ये तो तुमको पता होगा. नहीं पता है, don't worry, continue. So for steady flow, I can say that for incompressible fluid flow. For incompressible flow, I can say that density is going to be constant, means rho 1 is equal to rho 2. So if I put it here, what I will get beta? यहाँ A2 आएगा. So I will get A1 V1 is equal to A2 V2. This is a very common equation used in throughout the syllabus. Every single place this equation is basically used. So this is what? This is one dimensional beta. This is one dimensional only. Second constraint is steady flow. Flow should be steady flow, and fluid should be incompressible. Then only you can use beta. This equation is always number of time students are A1 is equal to A2. A1 is equal to A2 क्या होता है जी? You must know that what are the constraints. So constraints क्या है यहाँ पे? अरे constraints are one dimensional steady flow incompressible flow. Clear है? अरे समझ में आया क्या सर? ये तो बहुत आसान है, मजा आ गया सर. वेरी गुड. बट व्हाट अबाउट 3 डायमेंशनल सर? व्हाट अबाउट 3 इजी पढ़ा रहे सर, इजी पढ़ा रहे. ओके, don't worry, I will not teach only easy. I will teach somewhat difficult things also. Okay, let's talk about, but before discussing beta, before discussing the 3-dimensional continuity equation, right? Let's talk about the discharge. Discharge means volume flow rate. Discharge is known as what? Volume flow rate beta. It means that Q is equal to what? Q is equal to volume flow rate. Volume flow rate क्या होता है? That is volume per unit time, right? Volume flow rate means whatever volume is going to be flow per unit time. Okay, volume is area into L by time, or L by time क्या होता है? That is velocity. So I can say that Q is equal to nothing but AV. Q इज इक्वल टू व्हाट, क्या होता है, क्यू वी और ए क्या होता है, ओके. नाउ फॉर 1D 1 dimensional study flow incompressible flow for क्या पढ़ा था अभी, जस्ट बताओ भैया, जस्ट क्या पढ़ा, A1 V1 इज इक्वल टू A2 V2 और वी कैन से AV इज इक्वल टू कांस्टेंट. अरे AV इज इक्वल टू कांस्टेंट पढ़ा था, इट मीन्स दैट Q इज इक्वल टू आल्सो कांस्टेंट. मीन्स आई कैन से दैट the discharge is constant for 1 dimensional steady flow incompressible fluid. Discharge is always constant for 1 dimensional steady flow incompressible fluid. अरे क्लियर हुआ, क्लियर है. जावेद शेख, जावेद, जयचंद, कैप्टन राज, रमेश, पुलकित, पुरोहित, प्रियांशु, चंदन, SK, बाबू, क्लियर है दिस पॉइंट. Okay, very good. Stop. But here basically I am going to talk about the continuity equation in differential form, right? I am going to talk about differential form in all the direction, right? So for that what I am going to do is I am going to take I have taken one fluid element. This is what, ये सामने क्या दिख रहा तुमको, this is a fluid element. This is a fluid element I am taking. Now this is and this I am drawing here. Red color I am drawing. So this is basically what our axis. This is origin. This is origin. This is origin. This is axis. So this is basically x-axis. This is basically, let's say, y-axis, and this is basically z-axis. Right, z-axis. Right. Now please listen. This is, let's say, I will write delta x. That's fine. Delta x. This I am writing delta z. And this is the delta y. Delta y कहाँ जी, delta y इधर लिख देते हैं, delta y. So I have taken one fluid element. I have taken one fluid element beta. I have taken one fluid element. Right. I have taken one fluid element, and in that fluid element I have taken origin at this particular point. So x is this direction, y is this direction, z is this particular direction. And delta x, delta y, delta z हो गया, right? Now please listen here carefully. Please listen here carefully. Now I have to analyze the mass flow rate. Basically, we have to analyze them. We have to apply the mass balance. So here the mass can flow in 3 direction. Obviously in x direction, y direction, and z direction. So सारी direction देखें. Let's start with the direction number x. Right? Let's start with the direction x. So here how much? What is the mass flow rate? X direction में बात करें. X direction में मतलब ये फेज होगा, ये हो गया, लेट्स से A B C D. So the mass is entering from A B C D. It may be leaving also. If leaving, then minus sign will use. And here I can say A dash, B dash, C dash, and D dash. Clear है? So I have taken, this is basically what, one element I am taking here, one side I am taking. This is the one side I am taking. Okay. Similarly here also going to do the same. Now please tell me one thing. Please tell me one thing. What is the mass that is entering here? What is the mass entering? Mass entering ABCD. ABCD mass entering is rho AV. Now I already told you in last class also that velocity vector V is written as UI plus Vj plus Wk. This we already seen, right? Like UI plus Vj plus Wk. Now what is U here? U is the velocity in x direction. U is the velocity in x direction. V is the velocity in y direction. W is the velocity in z direction. Very good. Very talented, sir. You are very talented. Thank you. Thank you. I am very talented. I know that. Now, so this is basically thing. So in this direction, we are talking about x direction. X direction. What is the velocity? Velocity is u. Velocity is u. Okay. So now if I write mass flow rate, mass is rho AV. V velocity is what? U, right? So rho into A into V. U into A. Area कितना हो गया बेटा? Now इधर area you can see that delta y, ये delta y हो गया और ये delta z हो गया. So this is delta y and delta z. Clear है? Yes, sir. Now come to this side. Now some mass is leaving out, right? So how much mass is left? By Taylor expansion. You have to write the equation by Taylor expansion. This is, we already discussed Taylor expansion many number of time. I told you earlier also that z is a function of x and y. Then dz is equal to dou z by dou x at constant y plus into dx plus dou z by dou y at constant x into dy, correct? So that equation we see na, same equation form here I am going to use. So here if it is entering here, so how much it will change, even much detail I told you, right, in our previous classes. So if you don't watch that class, go and watch. Okay, now so I am directly writing beta. So here variable is what, see, area is not changing, whatever area, are bhaiya area at entry area is what, entry area is delta y delta z, and leaving is also delta y delta z. So basically area is not changing, not changing, not changing. So area is not changing. What is variable? Rho is also variable, u is also variable. See, rho for incompressible flow, rho is also not covered, but I am drawing a general equation. Abhi maine incompressible nahi liya, for incompressible, compressible, all. So what I can say that dou u is going to be dou u is going to be what? Dou u is going to be variable basically. So here dou u is basically variable. So I can say that it is going to be dou u, z को ये delta by delta z को common कर लेंगे, plus dou by dou x of this change of this variable, dou u into dx dz dy. क्लियर है? ये पॉइंट समझ में आया क्या? दिस इज कमिंग फ्रॉम टेलर एक्सपेंशन. दिस इज बेसिकली कमिंग फ्रॉम टेलर एक्सपेंशन. लेट्स टॉक अबाउट द वाई डायरेक्शन और जेड डायरेक्शन, एनीथिंग यू कैन राइट. सो लेट्स से वाई डायरेक्शन में एक बार देख लेते हैं. सो वाई डायरेक्शन लेट्स से एंटरिंग लाइक दिस. वाई डायरेक्शन इज एंटरिंग लाइक दिस and leaving like this. So entry is what beta? Entry I can say that rho into v, right, because in y direction velocity is what? V, right? So rho into v into area is what? Area is basically delta x delta y, delta x delta z, delta x delta z. So how much it will leave? Leave is also same thing you can write Taylor expansion thing. So I am writing from here, set rho into v plus dou by dou y of rho into v into dy into delta x delta y delta z, delta x delta z. Clear hai? So this is basically what in the direction of y. Let's talk about the z direction. So z direction, this is the positive direction. So I can say that I'll start from this side. So here it is entering is w velocity. So rho into w into area क्या होगा? What is the area in z direction, बाबू? That is delta x into delta y. Now how much it is going to leave? That is leaving value will be rho into w plus dou by dou z of rho into w into dz into delta x delta y. This is from Taylor expansion, right? So in all these three direction I am concluding here. Okay, clear है? किसी को कोई confusion है तो हमको बता दो, अब भी बता दो, just अब भी immediately बता दो, कोई problem नहीं है, मैं clear कर देगा, right? Okay, so now I am going to write the equations. Now I am going to write the equation in x direction. Right? What I am going to do? I am going to write the equation in x direction. So for x direction I am going to use this equation. What is that? What I am going to first I am going to find out. First I am going to find out that what is m input minus m out in x direction. Just I want to find this कि x direction में क्या m in minus m out है, मतलब net accumulation क्या है x direction में. So m in minus m out I just want to find out in x direction. So how much it will come बेटा? देखो जरा पीछे x direction में इस entry is rho into v, right? Rho into u. So entry is rho into u into x में है तो डेल्टा y डेल्टा z होगा, राइट? माइनस m आउट क्या है? m आउट क्या है बेटा? m आउट है रो इंटू यू प्लस by dou x of rho into u into डेल्टा y डेल्टा z. क्लियर है. नाउ अभी ये दो रू ये तो कैंसिल हो जाएंगे, राइट. सो रो यू तो कैंसिल हो गया, राइट. रो यू कैंसिल आउट हो गया. सो फाइनली क्या बच रहा है, माइनस डो बाई डो, केवल ये वाला टर्म बचेगा बेटा. सो डो बाई डो एक्स ऑफ रो इंटू यू इंटू डेल्टा एक्स डेल्टा वाई डेल्टा जेड. अरे यहाँ एक्स भी तो आया था ना. Right, this is basically m in minus m out in x direction. Similarly what I can write, m in minus m out in y direction. Y direction में क्या होता है बेटा, tell me. m in minus m out in y direction value will come dou by dou y of rho into v into delta x into delta y into delta z. Clear है. Now similarly I can write in z direction, m in minus m out in z direction value will come minus rho by rho z, dou by dou z of rho into w into delta x delta y delta z. Clear है. This is similarly I have written in all the three direction. But what is our main equation? This is our main equation. अरे व्हाट इज लॉ ऑफ कंजर्वेशन ऑफ एनर्जी, ये है लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. दिस इज लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. बेसिकली दिस इज लॉ ऑफ कंजर्वेशन ऑफ एनर्जी. सो हियर आई वांट टू पुट these values. Basically these values I want to put here. It means that the rate of mass entering in all the direction, so if I write here, is next slide में लिख दूं मैं. Okay, so I can write here by law of conservation of energy, by law of conservation of mass, sorry, not energy, law of conservation of mass or mass balance, that is also called as what, mass balance. So by mass balance what I can write beta, please listen here carefully, please listen here. Total m in minus m out. So m in x direction plus m in y direction plus m in z direction minus m in x direction, m in y direction, z direction. So that will become like m in minus m out of x direction plus m in minus m out of y direction plus m in minus m out of z direction is equals to the stored or rate of mass accumulated within the control volume. So that is m in minus m out is equal to rate of mass accumulated, means rate of mass accumulated d by d tau of m dot, rate of mass accumulated within the control volume, right. Now please listen here carefully, इसमें क्या लिखा था, okay, like rate of that is a change in mass of the rate or rate of mass accumulated within the control volume, this one, right. Now m in minus m out को क्या लिख सकते बोलो जरा. I can write here m in minus m out of x direction plus m in minus m out of y direction plus m in minus m out of z direction is equal to dou by dou t of mass. Mass क्या होता है, रो इंटू वॉल्यूम. सो आई कैन dou by dou t of रो इंटू वॉल्यूम क्या है इसका, डेल्टा एक्स डेल्टा वाई डेल्टा जेड. क्लियर है. अब इन सब का वैल्यू रख दो. इनका वैल्यू क्या था बेटा, इसका वैल्यू माइनस सब में कॉमन हो जाएगा. मैं तीनों को एक साथ लिख रहा हूँ, माइनस सब में कॉमन हो जाएगा. सो डो बाय डो एक्स ऑफ rho into u. Now delta x delta y delta z is also common, right. So plus dou by dou y of rho into v plus dou by dou z of rho into w is equal to ये डेल्टा एक्स डेल्टा वाई डेल्टा, अच्छा इसमें है, सॉरी इसमें रिमेनिंग क्या बचा है, delta x delta y delta z, right, is equal to this term is common. So delta x delta y delta z is constant ना, so constant differential के बाहर आ गया. So dou by dou t of rho. Clear hai? Now this term is going to be cancel out. This term is going to be cancel out. Clear hai? This term is going to be cancel out. So if this term will be cancelled, so final equation what you are getting, all these term I am taking another side. So basically this term is dou rho by dou t plus dou by dou x of rho into u plus dou by dou y of rho into v plus dou by dou z of rho into w is equal to 0. Now this is called as what? Continuous equation in 3-dimensional. Differential form of, this is a 3D differential form of continuity equation for 3D, 3-dimensional. This word 3-dimensional. It is applicable in all the cases. If let's say if let's say study flow, if I am talking about study flow, right? If I am talking about for study flow के लिए क्या हो जाएगा बेटा? For study flow dou rho by dou t का वैल्यू क्या हो जाएगा? 0. Dou rho by dou t का, अरे स्टडी का मतलब होता है the property is not going to change with respect to time, with respect to space it can change. So x y z वाले कंपोनेंट रहेंगे, लेकिन t वाला कंपोनेंट क्या हो जाएगा? वो हमारा कैंसिल आउट हो जाएगा. क्लियर है? वो वाला क्या हो जाएगा? हमारा कैंसिल आउट हो जाएगा. सो फाइनली इक्वेशन क्या बचेगी? फाइनल इक्वेशन बचेगी dou of dou x, dou by dou x of rho into u plus dou by dou y of rho into v plus dou by dou z of rho into w is equal to 0. This is for study flow. Clear है? ये clear हो गया? Done है? Okay. Now if it is incompressible flow, for example I am applying here that for एक slide मुझे add करना पड़ेगा. Okay. I need to add one slide here beta. So if I write for incompressible flow, so incompressible flow means rho value is going to be constant. Incompressible flow means rho value is going to be constant. Now rho is not dependent upon anything, not to time, so not only space. So what is going to happen by finally? So in this equation, first term dou rho by dou t value will be constant, because if it is incompressible means rho value is not going to change whether is a time or space, whatever. So it is not going to, and here rho will be common. Here rho will be common means it will be come out from differential basically, right? So I can say that dou rho by dou t plus dou by dou x of rho into u plus dou by dou y of rho into v plus dou by dou z of rho into w is equal to 0. Clear hai? Now we are talking about rho is constant. If rho is constant, so this value will be 0 and rho will be common here. Common means it will come out from the differential and then take common and it will go another side 0. So basically you will get dou by dou x, dou u by dou x plus dou v by dou y plus dou w by dou z. So this is the continuity equation which is most important for us. Why? Because we are dealing with incompressible, right? So this is a continuity equation for incompressible fluid flow. Now tell me, it is valid for study or unstudy? Sir, here t term is not there, that's why it is for study. No, whether it's a study or unstudy, it's valid for both. Valid for study as well as unstudy. Right, continuity equation for incompressible fluid flow valid for study as well as unstudy. So this is all about continuity equation. This is all about what? Continuity equation. Clear hai? So these terms I already wrote here. You can see that for steady and compressible, what will happen? This dou t by here, actually one term was there, dou rho by dou t plus this value. So this term is going to be cancelled basically. This term is going to be 0 basically, right? Now steady and incompressible is there, and whether steady word you use or not, this is valid. This is valid for steady and incompressible also, and unsteady for incompressible also. This is valid. Unsteady for and incompressible, this value is okay. See here, in this one also you can say rho value is common basically. Rho value is going to be common, and rho is not depend upon the time frames also. Rho is not depend upon the time frame as well as space frame, because when I am saying that fluid is incompressible and you are going to apply the pressure, then volume is not going to change. Volume is not going to change, density is also not changing, and this density is not only changing with respect to space, with respect to time also, because it's not changing. So either you are measuring at t is equal to 0 or t is equal to 1 or t is equal to 2, so that value is not changing. So this term will also be 0, right? And this rho will go in this side, that will be also 0. So basically this equation is good. This equation is going to be valid for both. This equation is going to be valid for both. Clear hai? Okay. So this is all about today's class. Like if anyone have any confusion, so you can tell me, no problem. Right. If anyone have any confusion, any doubt, you can ask here. Okay? And few more things I would like to share here. That is a common routine for the class. So you just write, and okay, few promotional thing I will tell you here. That one information is there that one Brahmastra batch is launched, right? This Brahmastra batch is basically for Plus as well as YouTube. So you can join any one batch. If you can afford Plus batch, you can come in Plus batch. Otherwise YouTube batch you can join. That will be free of cost. And here all the top faculties are going to teach, including me, right? So these are the basically differences, that if you are joining Brahmastra batch for YouTube and Brahmastra batch for Plus, then in both the batches top educators are going to be teach, right? But like DPPs are there, live classes, mentorship, all these things you will get only for Brahmastra Plus batch. And if you want to join this batch, then you have to use code SHIVAM101 to get the maximum discount. Clear hai? Similarly, one Gurukul batch is started for GATE 2024 students, right? If you are GATE 2023 student, then you have to join Brahmastra batch, right? And if you are a GATE 2024 student, then you have to join, you can join to the, you have not necessary, but you can join this Gurukula batch for GATE 2024. Here also all the top faculties are going to teach, right? And if you want to subscribe, then you can use my code to get maximum discount. Okay, these are you can take either Plus subscription or Iconic subscriptions. The difference is like in Plus subscription you are going to get all the live class from the top educator, digital note, essays, everything. Minimum requirement is going to be fulfilled. But if you want something extra, like you want customized doubt clearing sessions, personal guidance, as well as live mentorship program, and material that also hard copy material you want, then you have to join Iconic. So these are the fee structure of subscription, like either Plus or Iconic. And here whatever price you can see here, that is before the discount, right? If you use my code, again you have to use my code. I'm not saying that you have to purchase the course, but if you are purchasing, then you have to use only my course. Why? Because if you use my code, you will get my personal guidance throughout the completion. Okay, then if you don't have money, then also we have option, then no cost EMI option is there. Okay, and then next one is like okay, some people are preparing for GATE 2023, and for that 4 months subscription is there that you can choose. That is only 19,240, and if you use my code, then again it will be nearby 16,000 or something. Okay, And one new thing is launched. This is launched today itself. This is launched today itself, that 15-month plus subscription. Earlier there is no provision, like earlier there was like 12 months subscription was there, directly 18 months was there. Now 15 months is also there, and that cost is also very very less. Means if you are going to join plus, then 47,999, and iconic 58,999, and in that also you need to use my code SHIVAM101 to get maximum discount. So it will be reduced, further reduced, like minimum 5-6,000 you will get discount. Okay. Now one more thing, if you want even more discounts, then you have one option that you can write this scholarship test, right? ESE GATE Combat, and this is going to be happen, like this will be conducted in October 23, 2022, right, at 11 a.m. So 23rd October ko 11 a.m. that test will be there, and in this one 20 question will be there in 60 minutes, and if you are getting rank 1, then 90% scholarship will get. If you are getting 2 to 5 rank, then 70%. If you are getting 6 to 10 rank, then 50%, and 30% you will get if 11 to 50 rank, and this one. Okay. But here also, to give this test also they will ask for, because this test is actually free if you are using some promotional code, and that code will be, you can use my code. Again, what is sir your code? SHIVAM101. सर कितने बार तो लिखते रहते हो पूरा दिन कोड कोड कोड, right? Okay. Now the next one is, now you can earlier there is no option of purchasing this physical notes, right? So hard copy. So if you want to purchase hard copy, then you have to you have to go under self study, and in self study there is an option of physical notes, and that will be delivered to your door, right? So you just have to purchase it, and you have to fill the delivery address, and it will be delivered within 10 days. Okay. So this is all about today's class. If anyone have any doubt still, you can ask, otherwise we'll stop. Tell me. Okay, shall we stop here? Okay, so we are going to stop here. We'll meet tomorrow at the same time, 6:30. Tomorrow 6:30 we'll meet. Okay, bye bye.